Imagine this. You finally invent a time machine. The machine hums with energy, space-time bends, and you step inside. You set the dial for the past. A time before your parents were born. You arrive, and there's your grandfather, young and alive, unaware of who you are. And then, in a twist of fate, you cause his death. Maybe intentionally, maybe by accident, but the result is the same. Your grandfather never has children. Your parent is never born, and that means you never exist. But wait, if you never exist, then who built the time machine? Who traveled back? Who killed your grandfather? If you never went back, then your grandfather survives, your parent is born, and you eventually exist again, which means you do go back, which means you do kill him, which means the cycle loops forever. This is the grandfather paradox, a logical black hole in the fabric of reality. What exactly is a paradox? A paradox is more than just a puzzle. It's a situation where reason and logic break down, where yes and no are both true and false at the same time. The grandfather paradox isn't a fun riddle. It's a direct challenge to the way we understand time, space, and cause and effect. It asks, can the universe even allow contradictions, or would it collapse under the weight of its own logic? Before we untangle the paradox, we need to understand the stage it plays on. Time itself. To us, time feels like a flowing river. The past is gone, the future hasn't happened yet, and the present is all we have. But Einstein shattered that view. According to relativity, time is woven together with space into a single entity. Space-time. In this model, the past, present, and future don't vanish. They all exist, laid out like a map. You don't destroy your past birthday just because you had it. It's still there, written into space-time. That's why some physicists describe the block universe, a reality where every moment exists forever. If this is true, then time travel doesn't mean rewriting history, it means navigating it. And that's when paradoxes strike. At first glance, time travel sounds like fantasy, but physics actually allows certain forms of it. If you travel near the speed of light, time slows down for you compared to everyone else. This has been measured with atomic clocks on planes. In a sense, astronauts are already time travelers, moving fractions of a second into the future. Einstein's equations suggest space-time could fold into tunnels connecting to distant points. If one end is accelerated close to light speed, it might not just connect different places, but different times. Certain mathematical solutions to general relativity allow loops in space-time, paths that return to their own past. On paper, these are possible. Physics doesn't forbid time travel, but it also doesn't protect us from paradoxes, and that's where the grandfather paradox tears everything apart. You exist, you build a time machine, you travel to the past, you kill your grandfather before your parent is born. Your parent never exists. You never exist. If you never exist, you never built the time machine. If you never built it, you never traveled. If you never traveled, your grandfather lived. If he lived, you exist again. Round and round it goes, a logical merry-go-round that never stops. 1. Novikov's self-consistency principle. Russian physicist Igor Novikov proposed that paradoxes can't happen. The universe is self-consistent. That means if you travel back, your actions were always part of history. You can interact with the past, but you can't change it. So maybe you go back intending to kill your grandfather, but you slip. The gun jams. A stranger intervenes, something prevents it. Your attempt becomes part of the timeline that led to your birth in the first place. In this model, time travel doesn't rewrite history, it fulfills it. 2. The multiverse solution. Another possibility comes from the many worlds interpretation of quantum mechanics. When you go back and kill your grandfather, you don't erase yourself. You simply create a new branch of the universe. In one branch your grandfather dies and you were never born. In the other he survives, and you exist. Both are real. Both continue. The paradox disappears, but at the cost of spawning infinite realities. 3. The causality protection hypothesis. Physicist Stephen Hawking suggested something radical. The laws of physics may forbid paradoxes by preventing time travel itself. He called this the chronology protection conjecture. Wormholes might collapse, exotic matter might not exist, and any attempt to build a time machine might fail. Not by bad luck, but by the universe's own rules. In this view, the grandfather paradox is a signpost. It tells us, don't bother. Time travel is impossible. Imagine you write a letter to your younger self. In it, you tell them, burn this letter before reading it. If they obey, they never read the letter, so they never know to burn it. If they don't burn it, then they read it, which means they do know to burn it. The loop continues endlessly, A scientist invents time travel, goes back, and gives the blueprints to her younger self. The younger self never invents it, she just uses the plans. So who invented it? Nobody. The knowledge exists in a loop, without beginning or end. These are called causal loops. They're not just paradoxes, they're violations of how we think knowledge, cause, and existence should work. Quantum mechanics may offer a way out. At the quantum level, particles don't exist in definite states until observed, they exist in probabilities. Some physicists suggest that if particles can travel back in time, their interactions always work out in a way that avoids paradoxes. For example, a particle that could prevent its own existence simply finds another path. The probabilities collapse into consistency. Scaling this up to humans and family trees, however, remains speculative to say the least. The Terminator, a closed loop. John Connor sends back Kyle Reese, who becomes his father, Back to the Future. Marty McFly nearly erases his existence by interfering with his parents' romance. Doctor Who, Tenet, Interstellar, all play with the ideas of causal loops. Science fiction doesn't just dramatize the paradox, it shows us how deeply it resonates with our fear of breaking the chain of cause and effect. At its core, the grandfather paradox asks, can causality be broken? Causality is the backbone of reality. One thing leads to another. The seed becomes a tree. The match lights the fire. Without cause and effect, logic dissolves. The paradox forces us to imagine a universe where cause does not guarantee effect, where logic itself fails. That is what makes it terrifying. Maybe the grandfather paradox isn't a flaw in our understanding of time. Maybe it's a clue. A clue that time is not a river we can paddle against. A clue that the universe itself is built to resist contradictions. Perhaps paradox is the ultimate wall of physics, the place where imagination hits reality, and reality says, this far, no further. So, could you travel back and kill your grandfather? Physics answers, probably not. Either the universe prevents it, or it splits reality into infinite branches, or it simply refuses to let time machines exist at all. But the true power of the grandfather paradox is not in its answer, it's in its question. It forces us to confront the limits of knowledge, the fragility of logic, and the possibility that the universe is stranger than we can ever imagine. Maybe time is not a road we can rewrite. Maybe it is an unchangeable ocean, where every ripple has already been written. This was beyond Newton. If this journey into the impossible twisted your sense of reality, then don't forget to like, share, and subscribe, because out there, beyond paradox, the deepest mysteries are still waiting.